Okay, welcome to your extra review video 4. The first question says, Hannah incorrectly graphed the inequality 10x minus 5y is greater than 25 as shown below. Find and explain her two mistakes. So I know that she did two things wrong, but I don't know what they are. In order to find her mistakes, I'm going to solve it just like I would normally. So first I'm going to subtract 10x from both sides. When I do that, I end up with this negative 5y is greater than negative 10x plus 25, since the negative 10x and the 25 are not like terms. So then I need to divide everything by the negative 5 so that y is by itself. And when I do that, I get y is less than 2x minus 5 because I divided by the negative. This is an important step here, and there's a rule. When we divide by a negative, we have to flip the inequality. So then if I were to solve this, I would now continue by graphing. So I'd start at a y-intercept of negative 5 and use my slope to plot other points. So down 5, and then rise 2, run 1, rise 2, run 1, rise 2, run 1, and so on. And I'd stop there for now since it's an inequality. So to me, everything looks good so far. Next, what I would decide is the line type, because it's an inequality, and since it's less than, not less than or equal to, I'm going to use a dotted line. Oh, but Hannah used a solid line, so I found her first error. Okay, so now I would keep going, so that's one error. Then, in order to solve this problem, I would use a test point, 0, 0. So I'm going to do that off to the side on the right-hand side here. And then I would plug into the original, remember we always go back to the original, my test point of 0, 0. So that would be, if I plug them in and I get 10 times 0 minus 5 times 0 is greater than 25. Well, anything times 0 is 0, minus 5 times 0, that's 0. It's just going to be 0 over here. So I end up with 0 is greater than 25, which is false. So since it's false, I should not shade where 0, 0 is. But wait, this person did shade where 0, 0 is. So I'm going to say that she shaded the wrong way, and it's likely because she didn't realize that when you divide by a negative, you flip the inequality, or she didn't use the test point correctly, or something went wrong along those lines. So I know that she shaded incorrectly. So I said she also shaded incorrectly, likely because she forgot to flip the inequality and use a test point. Because if we use a test point, that should tell us that we shouldn't have shaded where that was. So if we had y is greater than, it's probably that we forgot to flip the inequality. Okay, number 2, given the graph of f of x to the right, find the following. And I forgot to fill in these parentheses here. I wanted to find f of 2. So if we look over here, the x value we know in this is 2. So if I move f of 2, right 2, what's the y value that's paired with it? And that would be 1, because on my function, this line here, at an x value of 2, the y value is 1. So for that one, really, if you put any x value in with the y value that's paired with it from the line, that would be okay, since I didn't fill in the x value. But this is just one point on the graph. If my x value is 2, my y value is 1. Okay, so the domain. What's the furthest left that we go? Well, if I'm looking along the left-hand side of the graph, the first time I hit the graph is right here. That's at an x value of negative 3. So that's my domain. I could crop this picture in at an x value of negative 3. So I'm going to start there. And then if I look to the right, I see that I continue until this point right here, which is a 3. So I start at negative 3 and I go to 3, but remember that with domain and range, we also have to worry about parentheses and bracket. Well, the negative 3, since that's a solid point, there's no open circle there, that means that it is included in that. So I'm going to put that as with a bracket, and then 3, since there's an open circle there, that one's not included. So I have to put a parenthesis around that. Okay, and then the range, the lowest we go is negative 3, so I'm going to start again with negative 3. And how high do we go? Well, the highest we go is a 1, so negative 3 to 1, because there is no arrows on this graph, so no infinities. And I think that both of those are included since they didn't have any open circles in the bottom or the top, so that means that they're both included, so I'm going to use a bracket around both. Okay, on to number 3. Casey is printing pictures for a photo album, and the first 50 prints are 25 cents each. Each print after that costs 15 cents. If P represents the number of prints and C represents the total cost, write an equation to model the situation if over 50 prints are ordered. So I'm going to start off with C of P, which you didn't have to use because it didn't say a function, but I just like to. So C of P or just C equals is fine for this. So C of P equals the cost of my prints is going to be 25 cents, so 0.25 or 0.25, either one is fine, times 50 prints, because 50 of them will cost me 25 cents, But then I'm also going to buy more because it says that we're buying more than 50. So I'm also going to buy how many? Well, 15 cents for however many, I don't know how many, P, but I don't want to repay for the 50 that I've already bought at 25 cents each. So I need to subtract 50 from the number of prints because P is just the total number of prints that I have. So this is my equation, and we could simplify it if we wanted to, but we don't have to. The next part says that Casey thinks 82 prints will cost her $24.80. Do you agree with her and justify? Well, in order to find this out, I'm just going to put 82 in place of my P. So C of the cost of 82 prints this time. And it's going to be equal to the same function that we used last time. So 25 cents times the 50 that I have at that price, then 15 cents, so 0.15 or 0.15, either way is fine, times, and my number of prints this time is 82, so parentheses when we substitute in, minus the 50 that I already paid for, and I don't want to pay for it twice. Then we can go ahead and put that in our calculator because we can then let that do all the work for us, and we use parentheses and type everything exactly the way we see it, and then we would get our answer, which is $17.30. So the question here, this is just my justification. This was to find out if I agreed with her or not. It said that she thought it was going to be $24.80. And the question was, do I agree with her? So I'm going to say, I do not agree with her because 82 prints will cost $17.30. And my justification, the math to back me up, is right here. So that's my answer for that one. So I have my answer with my justification to back me up. Okay, number 4 here says solve for C in terms of A, B, and D. So basically I want to get C by itself. So the first thing that I see is that I have fractions here. So before I even worry about what's happening to C, I'm going to just get rid of the 5 in the denominator. So I'm going to do that by multiplying by 5. So if I start off by multiplying everything by 5, all the terms by 5, which really there's only 2, one on each side, this will cancel with this. So now I'm just left with 5a equals b times c minus d. Now I need to solve for c. So in order to get c by itself, what's happening to c? Well, we're subtracting d and we're multiplying by b. So I need to do the opposite in the opposite order. So first I'm going to do the opposite of multiply by b, which would be to divide by b. And remember, we divide all terms by b, but there's really only 2 terms here because this is all one big term on the right-hand side. So b over b cancels. I'm left with 5a over b equals c minus d. Now to get c by itself, I'm going to add d to both sides because that's the opposite of what happened next, is subtract d, so I'm going to add d. So when I do that, d over d will the negative d plus d will cancel, and on the right-hand side I'm left with 5a over b plus the d equals c. So now c is by itself, and I have a, b, and d in my answer. So that's it for that one. Okay, number 5, solve the inequality below, graph the solution, then state the largest integer value that would make the inequality true. So I have 3 things that I have to do here. I have to solve, then I have to graph, and then I have to state the largest integer value. So to solve this, let's start off with that. Well, I can see here that the 3 and the 6, I can do this in one of 2 ways. I can multiply everything by 3 first, and that'll cancel out my 3. Then multiply everything by 6, and that'll cancel out my 6. Or I'm going to, since I see that both of these have 6 in the denominator, I'm going to multiply them by 6. So the important thing here is to remember that we're multiplying all the terms, and I have 3 terms here. Remember that terms are connected with addition or subtraction. So what I did was I multiplied everything by 6 because that'll cancel out both denominators, because 6 times 2/3, or 6 times 2 is 12, divided by 3 is 4. So 4x, and then negative 5 times 6 is negative 30. And that's less than or equal to 6 over 6 will cancel this time. And 1 out front, if I distribute that, it's not going to change anything. So I'm just going to put the x plus 6 on the right side. Now I can solve this just like normal. Row over row over, bring the smaller x over. So I think x is smaller than 4x. So I'm going to subtract x from both sides. X minus x will cancel here. And I'm left on the left side with 3x minus 30 is less than or equal to 6. Then I'm going to add 30 to both sides. And then I end up with 3x is less than or equal to 36, and I'm going to divide both sides by 3. to finally get my answer of x is less than or equal to 12. Okay, no divided by negative or anything, so I don't have to flip the inequality, so I'm all done with that part. But that's only the first part. That was only the solving, so I've done the solving. But now I need to graph. So remember, to graph inequalities, we have to use a number line. And then we have to say, okay, where am I starting? And that would be my solution, which was 12. And then we pick 1 point higher, which would be 13, and 1 point lower, which would be 11. Then we have to worry about what kind of dot goes on the 12. Well, since it's less than or equal to, that means that 12 is included, so I'm going to put a solid dot on 12. Next, we gotta worry about which way to shade. Well, if we think about x is less than, we can always sub our answers that we put on the number line here, our numbers on the number line, in place of x in our answer. So is 11 less than or equal to 12? Well, yes, that is. So that is the way we're going to shade. So this is the way we're going to shade. These are where all our solutions are. So that's the graph. Now it says, state the largest integer value that would make the inequality true. Well, since 12 is included this time, we can say that 12 is the largest integer value because it can equal 12. So 12 is the largest integer value, and otherwise it would be anything smaller than 12. Since our shading is this way. So 12 is the largest integer value. Okay, so now I have done all three things just to be sure. I've graphed and I stated the largest possible integer value. Okay, on to the next. Okay, number 6 here says that if a equals 3x squared minus 2x plus 1, b equals 5x plus 8, and c equals 2x plus 3, express the following in simplest form. So I'm going to start by filling in a, b, and c in place of everything that's in a and b and c here. Okay, so I started by substituting everything in. When I do that, I'm using parentheses, I can see that I need to do what's in parentheses first. So I need to subtract these two first. Well, in order to do that, I need to distribute this negative to both things in the parenthesis here. So I have to distribute it to the 5x, which will make it a negative 5x, and to the 8, which will make it a negative 8. Then I have 3x squared minus 2x plus 1 minus 5x minus 8. Now I can go ahead and combine any like terms, and you can highlight them or underline them if it helps you. So I see that I have 3x squareds here and no more x squared, so I'm just going to write 3x squareds first. Next I have minus 2x and minus 5x, that's going to be minus 7x. And then I have plus 1 minus 8, which is going to give me negative 7. So I combined everything, and then I put my parentheses back in because now I need to multiply all of that by the 2x plus 3. So in order to do this, I'm going to set up an area model because I think that's the easiest way to multiply a trinomial times a binomial. So I'm going to fill in each of my boxes. So remember that we set it up by having a 2 by 3 grid over here so that I can fill them in the area of each one. So I have 3x squared minus 7x minus 7 in the top. And then I have the 2x and 3 on the side. So if I do each area of each little square, 3 times 2 is going to give me 6. And x squared times x is going to give me x to the third because we add the exponents there. Okay, and then the next box, now I'm going to do negative 7 times 2, which is going to give me a negative 14. X times x is going to give me x squared. So negative 14 x squared in the next box. And then in the following box, we have the negative 7 times the 2x. So if I do that, I'm going to get negative 14x. And then I'm going to move on to the bottom, which is 3 times 3. That's going to give me 9. X squared, and no x's to combine with, so that's just going to be 9x squared. And then we have 3 times negative 7 is negative 21. X, and then negative 7 times 3 is again the negative 21, and there's no x this time because neither one has an x. Okay, then once we've done all that multiplication, now we look for any like terms. Normally they show up in the diagonals, and I do see one here, negative 14 and 9x squareds. No 6x cubes to combine with, so first I'm going to start off by writing the 6x cubed because it's by itself. Then you can see on the diagonal, or even if we highlight them, we have the negative 14x squared plus 9x squared. That gives us the negative 5x squared. And then again, looking on diagonals for any like terms, I see negative 14x minus 21x. I can put those together, and that'll give us the negative 35x. And lastly, I have the negative 21, so now I'm just going to type that at the end there, minus 21. And that is my final answer for that question. Okay, next question. This next one says Justin is driving around to run errands. The graph below shows the distance away from home as he travels. Explain what he might have done between 20 and 30 minutes. Well, if I look at that part of the graph between 20 and 30 minutes, that means that I'm looking at this part right here. Between 20 and 30 minutes, I can see that time went by, but his distance didn't change. So I'm going to say that he stopped for something during that time. So I said Justin might have stopped to get gas or buy food. So basically anything that you want to say there, as long as you just say that he stopped for that amount of time. He was not driving during that time. Okay, then the next one says, during which interval was he traveling the fastest? Well, if I'm looking for him to travel the fastest, I'm looking for the least amount of time to go by where he has gone a far way. So if I look, this part right here that I highlighted in green, that is the steepest slope. In only 10 minutes, it looks like he went from 5 miles all the way up to 20. So he went really fast for that time. So I wrote 30 to 40 minutes because it is the steepest slope, or the distance changed the most per minute. That we could figure out by actually calculating the slope if we wanted to. Okay, part C says determine Justin's average rate of change between 0 and 20 minutes and explain what it means in the context of the problem. So if I just look from 0 to 20, so I'm going to find the slope for that. I'm going to start by writing out the points. So 0, 0, and 25. So remember, slope is y2 minus y1 over x2 minus x1. So I'm going to do 5 minus 0 over 20 minus 0. And when I subtract that, I get 5 over 20, which then reduces to 1 over 4. But I'm not done. It said in the context of the problem, so I have to put this in words. So this is the average rate of change between 0 and 20, but what does it mean? So it means that on average, Justin traveled 1 mile for every 4 minutes between 0 and 20 minutes. Okay, and the last question for this question says, how many miles did Justin travel all together? So what was his total? Well, if we look, he started at 0, he traveled 5, didn't travel, then he traveled up 20 altogether, right? Because it's 5, and then 5, 10, 15 more, so 20. And then if we look back, he traveled 20 back, so that's 40 miles altogether. So that's the part D answer. Okay, last question for this review. Sam is going to make a trail mix for her friends. She already has all the items to mix except for raisins and almonds. She goes to the store with $30 and doesn't want to spend it all. So we know that she's actually not going to spend all that she has. So she has $30, but doesn't want to spend it all. So she sees that raisins cost $2.50 a pound and almonds cost $3.75 per pound. So we need to write in an inequality. So we know that we're not having an equation. So it means no equal sign, either less than, greater than, less than or equal to, greater than or equal to represent the amount of raisins and almonds Sam can purchase. So let's start off with, we know that she has to spend less than $30. So I'm going to start with the $30. So 30 is the most. So what she spends is coming next. So that has to be less than. So I'm going to do 2.50 per pound of raisins, and I can see that raisins is on the x-axis, so I'm going to put an x there, plus the $3.75 per pound of almonds, and almonds on the y-axis, so I'm going to put a y with that. Okay, so that's my inequality. That's it for that part. The next part says use the grid below to sketch a graph of the equation. Well, in order to do that, and I know that this is all very tight, I have to solve my inequality, get it into y equals form. So first, up here, I'm going to subtract the 2.50x over, so that gives me the negative 2.50x plus 30 is greater than 3.75y. Then I'm going to divide all my terms, so remember terms are separate of addition and subtraction, by that 3.75. And when I do that, I end up with negative 2/3 x plus 8 is greater than y. And now remember, because this is a real life question, we're going to go to my calculator, we're going to go to y equals, we're going to plug in our inequality, and that's because that'll tell us what we need to start with on our x and on our y, especially since if you look over here, there are no numbers on the x and y. So I need to know what numbers do I need to cover here. So when I go to my calculator, I get my table of values, 0, 8, 3, 6, 6, 4, 9, 2, and 12, 0. So that tells me that on my x-axis, I need to get up to 12. Well, if I have 20 spaces here, which I counted already, that means that I'm going to have to count by everyone being worth 1, because that'll get me to 20. If I made every other half, or a half for each one, and skipped, I'd only get up to 10. So I'm going to have to make every one of my x worth 1. Okay, so I labeled that. I just labeled every 5, but I'm counting by ones. Okay, now my y-axis needs to only go up to 8, so that means I can spread that out a little bit. So I'm going to make everyone worth half, or skip and count 1. Okay, so now I have all of that labeled, and since I have my nice points, now I can go ahead and plot them. So I'm going to go 0 up to 8, and I'm going to put a dot there. And then I'm going to go to 3, 1, 2, 3, up to my 6, and I'm going to put a dot there. At 6, I'm going to go up to 4, and 9, up to 2, and 12, 0. Okay, so I've got my points plotted. Now I need to decide what type of line, and since it's y is less than, I'm just going to use a dotted line. And now I need to use a test point to decide where to shade. So I'm going to go back to the original. Remember that we always go back to the original. And I'm going to test the point 0, 0. So if I put in 0 in place of x and 0 in place of y, I end up with 30 is greater than 2.50 times 0 is just 0. And 3.575 times 0 is just 0. So is 30 greater than 0? Yes, that's true. So that means that I am going to shade where 0, 0 is. So I'm going to shade all below this line. And remember that we don't have arrows on our line because we can't go into the negative, and my shading is going right up to my axes because I'm not going beyond. And then remember, we can put an S in here to say, okay, this is where all my solutions are in the solution region. And now I just think we're missing a couple of things. I'm going to label my line, and I'm going to label my graph. So now you can see that I have the 30 is greater than 2.50x plus 3.75y, and Sam's trail mix. Okay, and we've got one last question. Can Sam purchase 6 pounds of raisins and 4 pounds of almonds? Well, if I look over here, 6 pounds of raisins, that's on my x-axis right here, and 4 pounds of almonds, that takes me to this point right here. Well, I don't think she can because that's a dotted line. So I'm going to say, so I said no because the point is on a dotted line, so it is not part of the solution. This would mean she spent $30 and she does not want to spend all her money, because remember, anything on the line, if we substituted in for x and y, it would be equal on both sides. So that's it for this question. That's it for your extra review. Hope that you have a good night, and we will see you tomorrow.